Good day, grade 12s. Today we are discussing momentum and impulse. Before we go into calculations and problems, let us begin with definitions. There are 5 definitions you need to remember going to the exam or any task, any test. The first definition we deal with is the definition of momentum. We use the symbol P for momentum, so it's small letter p. Remember, capital letter P is used for power and is it power in electric circuits and power also in work energy and power. Also pressure, we use the capital letter P. So we use small letter p to denote momentum. The definition for momentum is the product of mass and velocity of an object. Excuse me. And it's if you write it as a formula, it becomes P equals to mv, which is simply the definition of the one that is said below. Secondly, we go to the other definition, which is Newton's second law in terms of momentum. It states that the net force acting on an object is equal to the rate of change of momentum of the object in the direction of the net force. And if we were to write this represent it using a formula, it's going to be F net equals to the rate of change in momentum. So it's change in momentum on top divided by change in time. And this is the Newton's second law in terms of momentum. Definition number 3, it's the one for impulse, and it states that the product of the net force acting on an object and the time the net force acts on an object. So in other words, we say impulse equals to the net force, the product of the net force acting on an object, and the time for which the net force acts on an object. Number 4 is not necessarily definitions and explanation. You are required to know or to explain the term isolated system. And we say that in physics, we say a system on which the net external force is 0. So F net is 0 in an isolated system. F net is 0 in an isolated system. Lastly, we have the principle of conservation of linear momentum. The total linear momentum of an isolated system remains the same, or it's conserved, or the total linear momentum of an isolated system remains constant. This simply says that the total linear momentum before a collision equals to the total linear momentum after the collision. And please note very well, you need to remember the definitions, study them very well. You need to remember them going to any exam, because each definition is worth 2 marks. So below I have the following, that since mass is a scalar and velocity, we know this from grade 10, velocity is a vector. So this means that momentum is going to be a vector quantity as well. When you multiply a vector with a scalar, you get another vector. And the units for momentum in this case, then it will be the unit for mass is kilograms, the unit for velocity is meters per second. So the unit for momentum becomes kilograms meters per second. Going further, momentum, the formula for momentum is P equals to mv, the one that we'll be using. Please check this out on the exam guideline. The exam guideline, download it on the Department of Education website, the 2021 copy, Physical Science Examination Guideline 2021. And you'll find on page 9 all these definitions that I just highlighted. Definition for momentum, definition for Newton's second law in terms of momentum, definition for impulse, the explanation of an isolated system, and the definition for the principle of conservation of linear momentum. Please read them, memorize them for the test, for any test that you'll be writing. this here. When you go to page 27 of your exam guide, this is what you'll find. You'll find the formula sheet for grade 12. And notice that I've highlighted already the formulas that we are going to use for momentum. They are found under the tab force, and this is the formula for momentum, formula for impulse, and the formula for changing momentum. The formula for change in momentum is, remember, since the velocity is a changing vector, the velocity doesn't remain the same all the time. So if the velocity changes, it means that the momentum will change as well. Change in momentum is written as final momentum minus initial momentum, or you can express it as the final momentum as mv final minus the initial momentum, which is mvi. Or if you factor the mass out, since the mass does not change, the formula becomes like this. And the other one, the third definition, second definition is Newton's second law in terms of momentum. We've seen the formula when we were doing our definition earlier on. And the definition of impulse is this one. Impulse is F net change in time. So it's, if you rearrange this formula in Newton's second law in terms of momentum, multiply both sides by change in time, it becomes like this. And we call this part impulse. And remember, this part will be equals to, because it will look like this, F net multiplied by change in time from here, equals to change in momentum. So if this part is called impulse, it's written as F net multiplied by change in time. But remember, also this part equals to change in momentum. So it means that impulse can be change in momentum. It equals to change in momentum sometimes. That is why you see in the formula sheet they've written formula for impulse as F net change in time equals to change in P, change in momentum. And that brings us almost to the last part of my formula. The last part is the law of conservation of linear momentum. Remember, it states that the total linear momentum in an isolated system remains the same, or remains constant. So this means that the total momentum before collision equals to the total momentum after collision. This is where we have more than one object moving or colliding. So we write it like this. Whenever there are two objects in a test, please write the total linear momentum before equals total linear momentum after. And we have three scenarios that we study in grade 12. Okay, there's more than three, but these ones are the ones that we find the most. Scenario number one is when we have two objects before collision, then they collide. This denotes collision. Then after collision, these two objects remain separated. They were separated before collision, they collide, and then after collision, they remain separated. So in this case, we have momentum of body number one, which is P1 initial plus P2 initial equals to P1 final plus P2 final. So this becomes something that looks like this. So it's momentum of M1 V1I plus M2 V2I equals to M1 V1 final plus M2 V2 final. So the momentum of object before collision, they are separated, so you add both their momentums. If there are three objects, you have to add all three of them. Momentum of body one plus momentum of body number two plus momentum of body number three. In this case, you only have two, so it's before collision and after collision. Then you start substituting into these values. Remember to choose the direction when you substitute, but you'll see that as you solve the questions after this. Number two, scenario number two is when you have two objects before collision, they are separated, then they collide. After collision, they stick together, they move as one body. So in this case, we have momentum of body number one, M1 V1 initial, M1 V1I plus M2 V2I. This equals to M1 plus M2, because now the masses are combined. multiply by final velocity. They move s1, so they have one velocity. Then you substitute, also take into consideration the issue of directions. Scenario number 3, we have two objects. Okay, we have one object and it explodes into two. So we may consider the issue of a gun and a bullet in this case. The gun and the bullet, they are in one body. And then once you fire the gun, the bullet will be moving in another direction and the bullet and the gun in a different direction. So in this case, we have mass of body 1 plus the mass of body 2. Initial velocity. They are combined. They have the same velocity before collision. And after collision, it's going to be mass 1 final velocity of body number 1 plus mass 2 final velocity of body number 2. But remember to start with change sum of momentum before equals to the sum of momentum after. Yeah, this summarizes the chapter in momentum. But now let's see how we solve questions in this chapter, because the most important thing in physics is to solve questions. Know how to solve questions. Let's have example number 1. I took this from one of the books that I use. The first problem is let's try zoom in it. And the first problem says that in exercise 1, a motorcycle with mass 200 kilograms moves at 12 meters per second in a direction northwest. Calculate the momentum of the motorcycle. So remember to write down everything that is given to you. So let's collect all that is given to us. We are given 200 kilograms, which is mass of the object. 200 kilograms. And then 12 meters per second in a direction northwest. So the velocity is equal to 12 meters per second northwest. The question says calculate the momentum of the motorcycle. So they want momentum. How do you calculate momentum? Momentum, remember the formula for momentum in the other paper. The formula for momentum is P equals to mv. So we start by writing the formula. P, the solution. P equals to mv. We substitute the value for the mass, which is 200 kilograms, and the value for velocity, 12. And you multiply this. So you multiply 200 multiplied by 12. You get 2400. And remember, the units for momentum is the units for mass is kilograms. For velocity is meters per second. So the unit for momentum becomes kilograms meters per second. And do not forget to write the direction, because remember, momentum is a vector quantity. So it will be in the direction of the velocity. The velocity was northwest, so this in the northwest direction also. Problem number 1 done. Let's move to another problem, which is problem number 4 in this book. It says that a rubber ball of mass 0.8 kilograms is dropped and hits the floor with an initial downward velocity of 6 meters per second. The ball bounces back with a final upward velocity of 4 meters per second. So calculate the initial momentum, calculate the final momentum, calculate the change in momentum of the ball. First of all, you need to write down everything given to us. Remember, we're given 0.8, 4 meters per second, 6 meters per second. That is all that is given to us. So the mass of this object, the mass is equal to 0.8 kilograms. Initial velocity, the velocity it was moving with before anything, it's 6 meters per second. And final velocity final velocity is 4 meters per second. This initial velocity, the direction of initial velocity is downwards, so it's downwards, and this one is up. So let's calculate now. Initial momentum, so initial momentum we calculate, it's P equals to mvi. Pi equals to mvi. Substitute the value of mass, which is 0.8. Substitute the initial velocity, which is 6. And you get 0.8 multiplied by 6. This gives you 4.8. So it's 4.8 kilograms meters per second in the direction down. 4.8 meters per second in the downward direction. So it's downward. Um, 4.2, calculate the final momentum. So final momentum, remember final momentum is PF, which is equals to mv final. The mass of the object doesn't change, only the velocity changes. So we have 0.8 again, multiplied by final velocity, which is now 4. And when you solve this 0.8 times 4, you get 3.2 kilograms meters per second. In the upward direction. Remember to do this. In a test, this will be a mark. Writing a formula is a mark. Putting the values into the formula is a mark again. Then the answer with the unit, correct unit, and the direction is another mark. So it's 3 marks. So if this was a separate problem, it was going to be 3 marks. The last question says calculate the change in momentum of the ball. Remember, change in momentum is we have 3 formulas that I showed you earlier. It's the first one where we have final momentum minus initial momentum, or we rewrite it as this, or the last one. But then remember, you need to choose direction now. In this case, which direction do you take as positive? Up positive or down positive? Let's take down positive in this case. Down positive. So we already have initial momentum and final momentum. It becomes easy then to say final minus initial. And when we substitute the values, final momentum is found to be 4.8 kilograms meters per second downwards, and we're taking down as positive, so we just write 4.8 minus this minus sign comes with the formula. The other one is 3.2 kilograms meters per second upward. I mean initial, sorry, excuse me, this is supposed to be initial, final minus initial. So this will be into negative 3.2. It becomes negative because now this is momentum that is in the upward direction because of the velocity that is upward. After it bounces on the floor, it goes up. So we put the value of direction there, I mean the sign for direction. And 4.8 minus into minus 3.2, you get 8 kilograms 8 kilograms meters per second. Oh wait, I made a mistake there. Let's fix this part. It's this 4.8 is not the final momentum, it's the initial momentum, excuse me. It's supposed to be change in momentum is final momentum minus initial momentum. So final momentum is this one, and it's going upward. Remember, we're taking down as positive. So it's negative 3.2 minus 4.8 minus the initial momentum. Excuse me there, I made an error there. So you get negative 8 kilograms meters per second. 8 kilograms meters per second. Now you don't leave your answer. Remember, this is a vector. You don't leave your answer as negative like that. You need to rewrite it as positive now and write the direction inwards. So change in momentum is equals to 8 kilograms meters per second. The negative direction we chose down as positive, so it means up is negative, so it's upward. And that's how you solve the first set of questions. Now let's see another set of questions where we calculate maybe impulse or F net use Newton's second law in terms of momentum. We have the following question. Exercise 2. in here we have a ball of mass 250 grams colliding with a wall at a horizontal velocity of 12 meters per second. The ball bounces back at a horizontal speed of 9 meters per second as shown in the diagram. This diagram. Let's zoom it in a bit. Now, what is the impulse? Okay, number one, calculate the change in momentum of the ball. Let's write down everything given to us. The mass of the ball is 250 grams. Remember, in physics, we don't use grams, we use kilograms. In chemistry, we use grams, but in physics, we use kilograms. So we need to convert this to kilograms by dividing it by 1,000. So 250 divided by 1,000 is 0.25 kilograms. This is the mass given to us. So the ball collides with the wall with a velocity of 12 meters per second. That is the first velocity we have, is 12 meters per second. And as shown in the diagram, you can see this is moving to the right. So this is moving right in the right direction. The other part is we are also given 9 meters per second in the left direction as final velocity. So final velocity is 9 meters per second left. So this is all we have. Question number 1, calculate the change in momentum of the ball. Unlike in the previous example, here we are given, we did not calculate momentum, initial momentum and final momentum first. So we go straight to the other formula. You'll find it in the formula sheet as well. It says the change in momentum of an object equals to the mass into final velocity minus initial velocity. I prefer to rewrite it like this, even though it's not given like this in the exam guide. But doesn't matter how you write it, just make sure you choose your directions and you write it correctly. So let us take right as positive. So to the right is positive. Substitute the mass, 0.25. Final velocity, it's 9 left, and we've taken right to positive, so it will be minus 9. Minus initial velocity is 12 to the right, so it's just positive 12. This minus sign comes from the formula, né? Remember that all the time. And then you do calculations, put it into your calculator. 0.25 multiplied by negative 9 minus 12, and you get minus 5.25. So it's negative 5.25 kilograms meters per second. It's negative, so rewrite it again as positive value, so it becomes, so it means that change in momentum is equals to 5.25 kilograms meters per second in the left direction. Question number 1.2, what is the impulse on the ball? What is the impulse on the ball? Remember earlier on we said that impulse is the product of the net force acting on an object and the time for which the net force acts on an object. But impulse equals to this value, impulse equals to this value, which is also equals to change in momentum, and we say that impulse equals to change in momentum. So the question says, what is the impulse? What is the impulse on the on the ball. So the impulse, the value of the impulse is the same. So impulse equals to 5.25 kilograms meters per second. The value of impulse equals to the value of the change in momentum. The last question. Calculate the force that the wall applies on the ball if the time of contact between the wall and the ball is 0.02 seconds. Let's have a free body diagram. If this is a ball and the wall and the ball are in contact for 0.02 seconds on the ball. Remember all the laws we use in science, right? So the ball will be pushing the wall towards the right hand side. This is going to be the force that the ball exerts on the wall. So it's FB on W, the force that the ball exerts on the wall. But remember, Newton's third law says that when object A applies a force on object B will apply the same force at the same time on object B. On object A. The force will be in opposite direction. So it means that the wall will also be applying a force on the ball. And this is going to be the force wall on the ball. So the wall is applying a force, the same force. Now the question is asking, calculate the force that the wall applies on the ball. This is the force they're looking for. In which direction is it facing? Yes, it's left. So the force that the wall exerts on the ball is the same as the force that the ball exerts on the wall, just that this one is to the left. And that is, if you use Newton's third law, is change. This is the only force acting on the ball, right? There's no any other force. We're ignoring the weight of the ball. So this is going to be the force change in momentum divided by change in time. We already have this change in momentum vector. Remember, it should be in the direction of the force, right? This is to the left and we are taking to the right as positive. So this will be negative 5.25 divided by 0.02, and negative 5.25 divided by 0.02, you get negative 262.5 newtons. Negative 262.5 newtons. So it means that the force that the wall exerts on the ball is equals to 262.5 newtons in the left direction. It's 262 newtons in the left direction. That brings us to the end of the second part of our chapter. Now let's go to the before we go to the next part, let's just leave it here, and then we'll have the other part separate, where we discuss the issue of conservation of linear momentum. Those three scenarios, remember the three scenarios, the scenario 1, 2, and 3. These ones, when you deal with conservation of linear momentum. The scenario 1, the two objects were separate before collision. Then they collide. After collision, they remain separate. And we represent that as momentum of body 1 plus momentum of body 2 equals to momentum of body 1 plus momentum of body 2 after collision.